Algebra 1 skills number 3, we're going to convert from English to English units, or the U.S. customary units, if you want to call it that. So first let's look at some of our units. Length, we need to know these numbers. 1 mile is 5,280 feet. 1 mile is also 1,760 yards. 1 yard is 3 feet, and 1 foot is 12 inches. Okay, so first part of this is just knowing those conversions, as they will not be given to you. Okay, so now let's look at how to convert with dimensional analysis. Let's say we want to know how many inches 6 feet are. Now, to some, it may be obvious whether you multiply or divide here. Okay, so you don't necessarily have to use this method that I'm going to show, but the method I'm going to show will remove any concern or any confusion about whether you should multiply or divide. So what we're going to do is draw this little set of fractions up. You always start with what you're given. 6 feet over 1. Anything over 1, of course, is just that something, but that gives it structure. And what we're going to do consistently here for the next little bit is, if you have a unit you're trying to get rid of, you want to put that unit on the bottom. So notice the red here. We have 6 feet. We want to put feet on the bottom so that the feet cancel and you're left behind with inches. Okay, so that's one concept. The other concept is this second fraction actually has a value of 1, okay? Because 12 inches and 1 feet are the same thing, 1 foot. When I multiply by 1, the value is retained, but what is not retained here are the units. So we're not trying to change the length, we're just trying to change the units. So I'm multiplying by 1, but my motivation here is to take whatever unit I have and put it on the bottom so that they cancel. And notice again, I put the converter that on the previous side, 1 foot is 12 inches. Now I'll multiply regular fractions, go straight across. 6 times 12, 1 times 1, and that would be 72 over 1. All right, notice the feet have been canceled, and 72 over 1, of course, is 72 inches. Now again, it may seem natural to you or common sense to you just to multiply and not write these fractions, and that's fine. But again, unless you have a good handle on it, there's the danger of being confused on when you multiply and when you divide. Let's look at the second example. 7,000 yards is equal to how many miles? And this may not seem quite as obvious as the first example. Again, dimensional analysis gives us sort of a template, kind of makes things straightforward and streamlined. So if I write down the original unit, 7,000 yards over 1, and again, I'm motivated to put yard on the bottom, and I need my converter. Since yard's on the bottom, I put it down there, I put miles, that's what I'm trying to go to on top. As we looked on the previous slide, 1 mile is 1760 yards. So notice the 1760 this time has to go on the bottom with the yards. Now when you multiply straight across, yards are going to cancel, but we have a division problem. Again, it may seem obvious to you to divide here, but this one, again, I would argue is not quite as obvious as the first one. And we divide to get 3.98 miles. That is rounded. So 7,000 yards is equivalent to 3.98 miles. Weight in the U.S. customary system, or English system. 1 ton is 2,000 pounds, and 1 pound is 16 ounces. Okay. So looking at third example, a sedan weighs 1.5 tons. How many ounces is this? Now this time we have to go through pounds to get 2 ounces, because it's generally not memorized how many ounces are in a ton, and sometimes you have to go through more than one unit to get where you need to go. So again, we start with tons, and we have to go through pounds. Now this LB is pounds. It comes from Libra is Y, but that's just a trivia fact. It doesn't really matter. This is just pounds. 1.5 tons over 1 is 2,000 pounds. Again, I know we're trying to get to ounces, but we have to kind of go through pounds to get there. So same as before in the first part, but then notice we have a third fraction now. Okay, you could have went ahead and multiplied here if you wanted to, but if we just multiply all at once, since I'm trying to eliminate tons, and now I need to eliminate pounds. So again, I'm motivated to put pounds on the bottom to eliminate that. So the red is going to cancel, and the green is going to cancel, and the unit you're left with is ounces. And because fractions are so easy to multiply, I can just go straight across, just multiply those, and multiply those. Let's take a look. Same place we've left off, 48,000 ounces. Notice that's the only unit that was not canceled. All ones on the bottom, so it's 48,000 ounces. Okay, so sometimes you have to go through one unit to get to another. Okay, liquid capacity. 1 gallon is 4 quarts, 1 quart is 2 pints, 1 pint is 2 cups, and 1 cup is 8 fluid ounces. Okay, let's look at a fourth example. A large order of soup contains 4 gallons and 3 quarts. How many pints is this? Okay, again, we're trying to get from, we've got gallons, quarts, and pints. So let's focus on this 4 gallons first. Okay, so what I did, 4 gallons, and this time I didn't color code, but because I start with 4 gallons, you always start with this, and then I write the converter. G is on top, so I need G on bottom. There are 4 quarts in a gallon. So 4 gallons is the same thing as 16 quarts. Okay, now, this doesn't answer the question, but that's helpful. Now I can read it. A large order of soup contains 16 quarts and 3 quarts. Well, 16 quarts and 3 quarts, that's 19 quarts. Okay, that's where the 19 come from. We got these extra 3 quarts. And now there's 2 pints and 1 quart. The quarts cancel. 19 times 2 is 38. So this is 38 pints of soup. That is a large order indeed. So there's hopefully lots of people eating that soup. But again, we have several units, so you kind of have to go 1 unit at a time. One more measure is time. 1 hour, 60 minutes, 1 minute, 60 seconds. Most people know that. Again, notice we don't have a direct conversion from hours to seconds. It's fairly easy to get there, but those are pretty well known. So here we're at, make it a little harder. A runner jogs 4 laps in 6 minutes, 12 seconds. How many seconds will it take to jog 1 lap? So not only do we have to do a conversion, we also have to go from 4 laps to 1 lap. So again, we have 6 minutes. That's 360 seconds. Most people are going to know that without having to write these fractions down. But again, I just do it for consistency and for structure to show that you could use the dimensional analysis. So 6 minutes is 360 seconds, but I also have these extra 12 seconds, so it's 372 seconds. So 372 seconds were used for 4 laps. So how many seconds will it take to jog 1 lap? Now we're going to assume here, and that's really all we can do, is that this jogger is jogging at the same rate. Okay, and in theory, in reality, you might think that maybe over time his energy lags and the first lap is the fastest lap. But a good jogger, if he or she knows how far he's going to jog, then all his laps or all her laps are going to be the same, or roughly the same distance or time. So 372 seconds divided over 4 laps would make 93 seconds per lap. So I didn't write the word lap there, but that would be 93 seconds for every lap. So that's English to English conversion.